So in tonight's first video, I want to talk briefly about Newton's first law of motion and inertia. You can find info about these on pages 112 and 113 of the textbook. After reading the textbook, you should be able to define Newton's first law and inertia. So Newton's first law has two parts. First, an object at rest remains at rest as long as no net force acts on it. So if you have something sitting on a chair, like a person, that person will sit on the chair unless someone pushes them off with a net force. The second part of Newton's first law, an object moving with constant velocity continues to move with the same speed in the same direction as long as no net force acts on it. So if something's going along, it'll keep going unless something stops it, like a wall. The property of matter that causes things to not want to change their motion, so the reason that things keep going or stay at rest, is inertia. And the word inertia actually means laziness. So inertia is the laziness of objects. Or more specifically, it is the tendency of an object to not change its motion. If something is moving, it doesn't want to stop moving. If something's at rest, it doesn't want to start moving or stop being at rest. So think about this question. If you were pushing an object and you stop pushing it, that's the question up here, and you stop pushing the object, does the object also stop moving? So I'm pushing something along, I stop pushing it, what happens to the object? If there's friction, the object will stop moving. However, if there is no friction, in the absence of any net external force, so no force like friction on it, the object will keep moving at a constant speed in a straight line, or if the object were initially at rest, it would stay at rest. And this is the law of inertia, or Newton's first law of motion. Objects at rest stay at rest, objects in motion stay in motion, unless acted upon by a force. And again, another way of thinking about the definition of inertia. Inertia is an object's resistance to change. No net force, no change in motion. So that means if you ever want to change the velocity of an object, and that could be the magnitude, the amount of the velocity, the speed, or the direction of the velocity, if you ever want to change something's speed or direction, a net force is required. Now, you've seen the word net force a lot, so let's think about this. Suppose I have a box. If that box is at rest, I could start moving it by pushing with 5 newtons of force to the right. And we'll cover what newtons are more later, but I'm just trying to give you an idea of how this works with numbers. So, if I push the box with 5 newtons of force to the right, then the box will accelerate to the right. A net force causes acceleration. However, if I push with 5 newtons to the right, and friction pushes back with 5 newtons to the left, if we add those vectors together, our net force is 0. If there is no net force, the velocity stays the same. So if the velocity were initially 0, it stays at 0. But if I do have a net force, I can either change something's direction or change its velocity. So in this post, there's a video with a bunch of inertia demos. It's only like 1 minute long, and it has 7 inertia demos. There's no explanation in that video. What I want you to do is watch it, and if you've already watched it, watch it again. Think about everything I've said in this video. Try to imagine how inertia and Newton's first law apply to each thing in there. Remember, this video is made super short so that if you need to rewatch it, you can. I've hit the key points, and tomorrow in class we will really dive in.